Perfect.
Yeah, okay.
Buenos días a todos.
Okay, I was logged out of my Zoom account. I'm really sorry for this. So again, sorry for the delay. And you can start and we'll wait for everyone. I mean, you can start and everyone will join. Yeah.
Okay, thank you. I'm going to share my screen.
Mm-hmm.
Okay, we will start. Loli takes the floor and later I will follow. Go ahead, Loli.
Okay, you can hear me?
Yes, perfectly.
Yes, okay. Yes. So good morning to everybody. I want to start by saying we're very thankful with these invitations that allow Sandra and me to have this opportunity to talk to you about the challenges our country, El Salvador, is facing regarding water management, and also to present to you a quick overview of some projects that we are working at the Centroamericana University to help monitor and prevent water pollution. The content of this presentation will be first present you some facts about the country, next some environmental figures to put you in context, and then we will present two projects, one related with a wetland, Cerrón Grande, and other related to the urban river restorations that is going on in our cities. And then we will explain to you what's next in these two projects that we were going to present. So here are some facts about our country. As you can see in this map, El Salvador is situated in Central America between Guatemala and Honduras, and is the smallest nation in the region. It is bordering the Pacific Ocean and is the only nation in the region without a coastline to the Caribbean Sea. It has a tropical climate with a rainy season from May to October and a dry season from November to April. El Salvador is a small country with a total surface area of almost 21,000 square kilometers. And this, for you to have an idea, is slightly smaller than the US state of Massachusetts. The estimated population is approximately 6.3 million, and this gives us a high population density, over 300 inhabitants per square kilometers. Also, 63% of our population lives in cities. Most of the population is concentrated in the central region where the capital, San Salvador, is situated. And the capital and his metropolitan area concentrates 30% of the population. So this high population density leads to high pressure to all natural resources and to high water demand. In this table, many of these figures are summarized, but we also can see that our dominant tropical climate results in an average annual precipitation of 1,800 millimeters. So therefore, El Salvador isn't a place where you expect to find water problems. After all, it gets nearly 6 feet of rainfall each year. But man-made environmental damages have affected the water cycle. And today, much of the surface water does not seep into the ground, replenishing aquifers, but instead flows uncontrolled, causing floods. Now I will present some environmental figures. In addition, El Salvador is one of the most deforested countries in Latin America, and that reduces the aquifer area of infiltration. We lack of tree cover in 67% of banks of main rivers, 64% of main water recharge areas, and 42% landslide prone areas. So this produces a very vulnerable scenario. We also have a problem with solid waste management. It is estimated that 800 of the 4.4 daily tons of garbage produced nationwide are not properly disposed, ending up in rivers and eventually the sea. Salvador is a very vulnerable country to disasters. It's among the 15 countries in the world most exposed to hazards and more vulnerable to natural events. 88.7% of the national territory is a risk area. So all this vulnerability mainly affects the poorest population. It is estimated that 600,000 households with approximately 2.6 million people are in multidimensionally poor. That means they present the following deprivations. 37% suffers from food insecurity, 94% do not have access to drinking water, and 83% lack access to sanitation. Surface water, regarding surface water, we can see in this map that is represented by 360 rivers distributed in 10 water regions. Although surface water are abundant, they are highly seasonal and generally polluted. During the dry season, from November to April, many streams ceases to flow. Although surface water is plentiful, biological contamination occurs nationwide, especially near heavily populated areas. Except for some primarily treatment facilities, all domestic effluents are released into the rivers and coastal areas without any treatment. Since 2006, the Ministry of Environment and Natural Resources make permanent monitoring of the quality and quantity of rivers water by collecting samples and analyzing parameters of water quality in 122 sampled sites in 55 rivers distributed around the country. In this slide, you can see the latest sampling results of 2020. The dots represent the sampling locations and the color mean the index water quality classification. For example, gray dots represent regular water quality. As you can see, no river has excellent or good water quality. 21.3% of the sites show regular quality, 71% present bad water quality, and 7% terrible water quality. So this pollution restricts the use that can be given to water. Of these 55 rivers, none have excellent water quality. 8 of the 10 hydrographic regions have high concentration of fecal coliforms, and 6 to 10 hydrographic regions show high concentration of biological oxygen demand and chemical oxygen demand. Besides rivers, surface water is also present.
Disculpa, María.
Sí?
Sí, can you explain what biological oxygen demand and chemical oxygen demand is?
Okay. This is analysis that is made to water in biological oxygen demand. You put water in incubation for 5 days and you see how much the oxygen is consumed, and is a test that gives you the microorganisms that are in water and how they can eliminate the organic compounds that are in the water. And then the chemical oxygen demand is like a complementary test, because in this test, you use chemical to oxidize all the organic matter that is in the water. So you oxidize the one that can be biodegraded and the one that cannot be biodegraded. So generally, chemical oxygen demand is higher than biological oxygen demand. I don't know if I can explain. It's two measurements of the amount of organic material that is in the water one for the organic material that can be digested by microorganisms, and the other of the whole organic material that is in the water.
Okay.
Mm-hmm.
Muchas gracias.
Okay. Besides rivers, surface waters is also present in the form of wetlands, which include lakes, small lagoons, estuaries. And some of them has been classified as Ramsar sites due to their ecological importance. As you know, healthy wetlands provide water quality protection, fish and wildlife habitats, natural water storage, flooding impact reduction, climate condition stabilization. But wetlands are among the most threatened ecosystems in the world, and El Salvador wetlands are not an exception. And climate change seems to be a new threat to wetlands, as it will reduce rainfall and increase temperatures and change flow regimes. Because of their importance, the Central American University was interested in working on these sites, on these water bodies, and we carry out work since many years in two of them. One, the Jiquilisco Bay, that is in the coastline, and which has the largest mangrove forest in the country. And the other one that's in the red circle is the Cerro Grande Reservoir, which is the largest freshwater body in the country. And now I will explain the work that has been done in this reservoir since 2016. To introduce you to Cerro Grande Reservoir, we have to present our main river. Our main river is called Lempa River, and is the blue line you can see in the slide. It's the largest and most important river in El Salvador, with its basin that you can see in blue, covering an area of 18,000 square kilometers. Of this area, only 10,000 square kilometers are in El Salvador. Almost half of our territory is this basin area. And the remaining basin area is shared by neighboring countries, Honduras and Guatemala. The Lempa River is the largest river system in all Central America, and its most important water use being for hydroelectrical power generation. There are 3 significant man-made reservoirs on the Lempa River, and these reservoirs store enormous quantities of water, and they are highly important ecosystems. The biggest one is Cerro Grande, which is marked here in red, and it estimates a surface of 135 square kilometers. And as I said before, is the biggest freshwater body in the country. Due to its international importance and on conserving biological diversity, these wetlands received the Ramsar designation in 2005, and the scenic beauty of some areas of the place is still impressive, and also provide water and food for the sustenance of local communities, allowing the commercialization of products derived from artisanal fishing and hunting. But despite its great relevance, as you can see in these pictures, the reservoir is currently threatened by the accumulation of solid waste, erosion, eutrophication that causes algae blooms, pollution, and presence of invasive species like water hyacinth. That is a floating plant that covers big areas in the reservoir. So understanding the current extent of wetland problem is critical for their management and control, to assess the potential impact on their ecosystem services, especially when we face challenges such as climate change, to develop management strategies for problems like algae bloom or invasive plant extreme abundance. It is necessary to predict when this phenomenon occur and what affects the timing, spatial extent, and intensity of the phenomenon. And moreover, it can be very useful when estimating the amount of biomass or of water hyacinth and phytoplankton available either for disposal or for exploitation. So in this first slide, we present the first phase of our work in the Cerro Grande, which was the monitoring of the spatial and temporal dynamics of microalgae and water hyacinth. To do so, we investigate these dynamics with 53 satellite images at Cerro Grande from August 2013 to August 2017. So the spectral signature of one of these satellite images was analyzed and related to the reservoir microalgae chlorophyll A concentration and to the reservoir water hyacinth biomass per unit of surface. These satellite images allow establishing a pattern of alternation between the bloom of phytoplankton and the proliferation of water hyacinth in the reservoir. During the years of observation, it can be recognized that phytoplankton, or here we can see water hyacinth that appears in the rainy season and then disappears from the reservoir. And then we have in the dry season, the phytoplankton appearance, and the maximum of phytoplankton is observed at the end of the dry season. Here you can see the dynamics of these superficial blooms of microalgae in the reservoir. So we observe in the years that this is reproduced each year in the same pattern. So the results also of this first phase show that the water hyacinth covers up to 30% of the water surface in the rainy season. And this is a problem for artisanal fishing and also deteriorates the water quality and balance of the ecosystems. We also managed to calculate the amount of water hyacinth dry biomass in the reservoir. We observed that it doubled between 2014 and 2016. And in 2016, it was calculated as 65,000 tons, the dry weight of this biomass. So this finding motivates a second phase of the project where we focus on identifying application in which this water hyacinth may be used as fuel or raw material for generating new value-added products. So the use of as biomass fuel, as construction material with properties similar to present wood, and as biogas production were evaluated as alternative, giving promising results. Besides water hyacinth, the result of the first phase also show a high presence of phytoplankton. And for this reason, the latest efforts has been focused on determining the species of algae that proliferate in Cerro Grande. The proliferation of algae in the reservoir is caused by the high pollution levels, since it provides too many nutrients that facilitate the growth of microorganisms. The result of this third phase have determined that the predominant species of algae are cyanobacteria, and 90% of the cell abundance correspond to the genus Microcystis, a potential producer of microcystins, which is a toxin regulated by WHO for water subject to human applications. So we think it's important to continue monitor not only the current state and changes of its water quality, but also the presence of invasive species, because this information is crucial for decision makers and stakeholders that are involved in the management of this important Salvadoran natural resource. Since the first phase of the project, water quality monitoring has been carried out, showing the high concentration of nutrients and organic matter that the reservoir has, and that is at the origins of its environmental problems. And this contamination comes from the rivers that pour into the reservoir and carry the untreated sewage of the major cities of our country. And one of these rivers is the Lempa River, that is at the center of the next project Sandra will present to you.
Thank you very much, Loli, and thanks to all for being here with us this morning. I'm going to start from one of Loli's previous slides. As she just mentioned, the Acelhuate River, the one you can see inside these red dots, is the most polluted river in the country. It's a river that goes all the way through the city, the main city, San Salvador, the metropolitan area of San Salvador, and ends up in the Cerrón Grande Reservoir. So what Loli and her team are doing in the reservoir, measuring all these pollutants and contamination in this area, is mainly due to the fact that we citizens are every single day dumping garbage and a lot of pollutants into the river and ends up in this area. So this is within the watershed of the Lempa River is this sub-watershed of the Acelhuate River. The Acelhuate River, as I mentioned before, goes all through the city, but is it contains within its watershed around 251 rivers and ravines that are connected to the urban system. These rivers and ravines that are located within the San Salvador metropolitan area are also hosting in very close to them around 800,000 inhabitants living in informal settlements. Normally, these people gets the water directly from these rivers and ravines that are contaminated. And since they do not have proper access to the formal water pipeline system in the city. So if we combine both the rivers and ravines, and you can see in blue the Acelhuate River, we found out that almost half of the population of San Salvador metropolitan area is living in these areas. So for us, from the urban planning point of view, the problem is not only a problem related to water quality, and provision of water services to the city, it's also a problem of housing, providing social housing, proper social housing to people, and providing also good living and livable neighborhoods to people living in these areas. So here you have a combination of what is most, the area that covers the metropolitan area of San Salvador, combined with the Acelhuate watershed. And as you can see, half of the river is within the city limits, is within the urban system. The other half is mostly in rural areas that are used for crop harvesting. And then in the upper part, you have the Cerrón Grande Reservoir. So all these projects we are working at the moment are strongly connected, and we are trying to see from this combined team of experts, how can we start solving this pollution problem and all the rest of urban problems associated. So the Urban River Restoration Project is something that we started in the year 2012. We asked ourselves, what about all these water systems within the city? And discovered that in the metropolitan area of San Salvador, we still do have beautiful river riparian ecosystems, rivers like this. This is the Quebrada Buenos Aires, one of the ravines we are working at the moment. And as you can see, the landscape, the tropical landscape of these areas is spectacular, but at the same time, it's quite polluted. We found bamboo forest, we have found tropical forest, beautiful if you do not see the contamination and the polluted water. But at the same time, we found that these areas are very strongly affected by city contamination. And as you can see, we are working in this area together with the inhabitants of areas at risk, housing areas at risk next to the rivers. But at the same time, there is this contradiction of the river being polluted, the river being a risk, but the river being a source of life and a source of water to the people living in the nearby areas. So another problem that we are facing, and in this context, is a high risk due to landslides and also flooding every single year during rainy season, which is, by the way, approaching. People living in all these very poor areas are really, really wondering, is my house the one that is going to be taken by the river this year? So the risk due to this human treatment of our urban context is really high in this area. So this is another aspect that we are taking into account. This just happened last year. We are working in this neighborhood at the moment, trying to fix this situation. But the problem is that it doesn't really matter what we do every single year to try to overcome these situations. Next year happens again. Because as I told you, this human affection, human beings affecting this area, mainly with garbage. Soil is quite unstable because layers and layers of garbage are being dumped in the rivers, and houses are being constructed on top of this garbage, as you can see in this image. So the situation is more or less like this. The formal city is just nearby the rivers, but we never really see the rivers. We are giving our back to the rivers. We normally build up high walls because we don't want to see them. And all these areas really close to the river canals are mainly informal settlements. So we have the formal city, next to the formal city, the informal settlements, and next to the rivers, all these combinations of walls and sometimes riparian forests. What we wish to have in the future is a city that is connected to the river, that these informal settlements are being transformed into sustainable neighborhoods, and that all citizens, not only from formal or informal areas, all citizens will be able to connect to the river to a series of public spaces that form a system that is providing the city not only the space to relaxation, but also a place where we could protect urban biodiversity and protect also this beautiful riparian forest that is still there. Obviously, this project depends on the fact that the rivers wouldn't be contaminated or polluted, and then it's where Loli's team is joining us to combine our expertise. So we started the project with the help of architects developing already projects in other parts of the world. We joined and still are working with Madrid Rio, a project that recovered 13 kilometers of the Manzanares River in the Madrid city. We also traveled with our students through the whole of Central America and learned from Costa Rica and Ríos Urbanos You could see our students visiting the Costa Rican sites in San Jose. We also invited our colleague Sandra from the Catholic University in Santiago de Chile. And she has been already for many years working as head of the Mapocho 42K, Mapocho 42 kilometers of the Mapocho River have been recovered for the city of Santiago. And together with Sandra, we thought, well, maybe from the Mapocho River, we could start this Acelhuate River project and trying to get back to the city 10 kilometers of the Acelhuate River. Also, we worked in 2016 with the Ministry of Environment in El Salvador, where we launched the project Agua del Acelhuate. This with the backup of the government, we initiated some actions to try to overcome this pollutant situation, the contamination of the river. And together also with private investors, we have been proposing small projects, pilot projects in several locations in San Salvador, where we could test some of our ideas in relation to some urban projects we are working at the moment in our office. So this is the basic of the recovery of urban rivers projects. But our questions right now, what's next? What are we going to do next with these two projects? I will leave the floor back to Loli so she can explain to you about further steps on her work. Loli?
Okay, thank you. As I said, we think it's very important to continue with the monitoring of water quality in the Cerrón Grande, but this is a very expensive task. The field work, the water analysis in labs is not cheap. So we are trying to look in the remote sensing techniques to set a system of monitoring the Cerrón Grande that doesn't need to go to the field. So this approach consists in using satellite images, and you try to relate these images to real water measurements, water quality measurements in the field. And then once you have this relation, you can apply these formulas to other pictures that come in the future. And so you can monitor the water quality without sampling at the site. And you can have like a alarm system or a continuous monitoring system. So we want to continue working on this direction so we can have some more permanent monitoring of the site.
Thank you, Loli. And as I mentioned before, we are now working on the Acelhuate 10K or Acelhuate 10K, 10 kilometers of the Acelhuate River from the upper basin, where the river originates. And we have already identified 10 different locations where we can work. And these locations are small urban projects, as I said, mainly related to public spaces, and in some cases also housing in high-risk areas, but they are all connected to public spaces systems in the city. So we want to open the city to the river systems and also join the river system with the public spaces already in the city. So by doing this, we hope that people will get acquainted with the river, but also will join us in a further project of the contamination of all these beautiful natural landscapes that we still have within our cities. So these are some images we are developing at the moment with my students and also at the office. I showed you the original image and the images we are working and doing with artificial intelligence and also with artist views of proposing ideas of how these places could be, could look in the future. As I said, social housing is one of our main issues. We are joining in our team with NGOs specialized on social housing and people that has already been working in these areas. And together with them, we are developing solutions of combination of public spaces, social housing, and certain infrastructure that could give the river back to the city, but also provide shelter and safe spaces. We are joining with, in this specifically with bioengineers from the Natural Life Science University in Vienna. And we are also understanding that some of the actual infrastructure of the city needs to remain over there, but what to do with these high concrete civil engineering landscapes, but combining it with other type of landscapes that we are also working with the students at the landscape program at Harvard, trying to figure out solutions that are possible to be implemented with the resources we do have at the moment. So public spaces systems, as I said before, is one of our main objectives to place in this area, but at the same time, we understand that this needs to be strongly related to not having all that foam that you can see in the image, and the real image, and just the way to have this aspirational image has a lot to do with attacking or working on this decontamination of the rivers. So this is what we have for you this morning. Thank you very much. Muchas gracias for your attention. And here we are, Loli and I, in our offices, our places where we work every day. We hope that maybe in the near future you will join us. So thank you very much, and we are open for questions and comments. Thank you.
Merci. Très bien.
Thank you very much for this presentation. This was very interesting. We're going to open the floor for questions. We usually open them online first. So yeah, Frederick, you want to ask a question?
Good morning. Thank you for the presentation. Two comments, remarks, or questions, because I worked on the problem of water quality with colleagues from the World Bank, and that we know it's very easy. It's that the pollutant types depend of the development level. So there is some that it's coming from more agriculture, more poverty, or problem to access to sanitations, for instance. And also there is what a network is oriented. So the solutions to solve problems depend sometimes on what happened on the top of the network and not what happened in the town itself. Mm. So do you have some analysis, or do you are interested to analyze spatial dynamics of the pollutants along the networks? Because there is very interesting work developing by colleagues from like Verhoef, perhaps you know him, in spatial statistics on networks like rivers. And it could be interesting to just understand the dynamics, the spatial and temporal dynamics along the networks. Perhaps to have some solutions more, I don't know, how do you say amont in English, but at the beginning of the
upstream.
Upstream, yes, upstream of the networks, and others that are more related to town development itself. So I think there is different strategies that we can imagine. And another thing is that remote sensing data, it's clearly very important and very good solutions to monitor water quality with less expensive to have some less expensive data, but it's clear that you have to calibrate information. And so, unfortunately, it remains important to keep ground data and to monitor data on the ground also, I think. Just to know, to be sure that there is clear relations between satellites and pollutants. No, it was just a comment.
Yes,
but I'm interested by these questions because I'm a statistician, and I'm interested by these spatial networks and to work on this kind of things. So, and we try to do it with colleagues from the World Bank. So we published paper in environmental research letters last year on the water quality. And unfortunately, this was not possible because data was not so good at the world scale level, at the world scale. But I'm really interested by this type of approach.
I think it's very interesting because we are clear that the cause of the problems in Cerro Grande are upstreams, are far away from the place, and the solution must be taken care of there in the where the problem starts. And it's very interesting this to follow the contaminants from the beginning to locate the solution where the problem starts. I think is very interesting. We're very interested to do that. And in the cities, I think it's imperative to have treatment to the sewage of cities because we don't have in the capital. And that's, I think, the main point of start constructing these facilities that can treat all this water that is going out all of these houses in our cities direct to the rivers now.
Yeah,
and
yes, but for example,
and then yes?
Sorry. For example, the oxygenation of water is also related to sanitation or the organic nutrient you have in the water. It's depending. So what we saw, it's depending on defecations mainly, for instance, and so it can move from upstream. So the concentration in town is also depending on what happened on top, and so perhaps to have some green treatment all along the river. I don't know. For instance, what we see in Europe compared to South America, it's that it's more the pollutant linked to agriculture. So modern pollutions is not the water quality is not better, but it's just the quality change, the pollutant changing. That's it. So we still have very poor quality of water in Europe, but based on modern strategies, polluants.
Okay.
Yeah.
Okay,
I think
if I might add something to the question is that in urban areas, what we see normally is that most of the pollutants come from domestic wastewater. 67% of contamination, water contamination in rivers and ravines comes from non-treated domestic water. So one of the main projects in the government agendas is to introduce water treatment plants. That's one idea, but obviously it depends very much on politicians, political decisions, and high investment from bilateral and multilateral organizations into the country. So this is something that takes time. The second source of contamination is solid waste, mainly plastics. And for that, a real strategy on how to treat plastic, but also citizens working on recycling. These initiatives just start together with some private companies. We join in our project with one of these companies that is recycling plastic, so that we could do some, at least in the sites where we work, we can do some cleans up. But obviously it's not enough. And but this is not really something that affects that much water quality. It affects, obviously, because you can see it, and in certain areas it's extremely complicated to try to overcome the situation, but some things can be done from municipalities and at citizens level. And the third source of contamination is a very specific industrial contamination that we have from certain industries that are already identified by the Ministry of Environment. Some of them are already implementing water treatment plants so that they can discharge their water, the water they use in the processes into the rivers with a certain quality. The problem is that 50 meters ahead from this discharges, the water is again contaminated and polluted. So the problem is not simple. And we understand that bringing back the riparian ecosystems and protecting the riparian forest and working with bioengineering solutions, we can diminish part of the problem, but is wider. So that working in these upper parts of the watershed before the place where Loli is working, so it takes generations, but we believe that if nobody starts to do this, then nothing will ever happen. So we already started. Probably we will not see the final results of our projects, but we already started. We are hoping to train students and to excite other young people to join our projects so that they can continue our work in the future.
Thank you. And I think we have time for one more quick question, either online or in the Maggie library. Yeah, Gail, go ahead.
Yeah, I have a question. So, muchas gracias por la presentación. Es muy interesante. Estupendo. My question is about what happens in Recife, Brazil, because they have more or less the same question with a big river crossing Recife, which was very polluted, completely like a dead river. And you had on one side of the river, on one bank, a very wealthy area, on the other bank, a very poor area with asentamientos informales. And I know they had, a couple of years ago, they had a big project, which is very close to the project you presented. Are you following this? Is it successful? Can you take inspiration from that?
Well, we are not following specifically Recife. We are working, as I mentioned, with Manzanares River in Spain, with Mapocho River in Santiago de Chile, with two rivers in San Jose, Costa Rica. We are joining also with people from Monterrey, to the Santa Catarina River and the Piedad River in Mexico City. So we have a very nice network. In fact, we have a network of urban rivers, recovering of urban rivers around the world. We just launched our first Congress last year. And we are learning from other projects, obviously. We are learning from different perspectives, different situations. we are learning from the ones that started, like Manzanares. They started in 2007, and they have been going through different phases on their project. So we get advice from them. Obviously, the situation, every single river is different, every city is different. In the Central American context, working very close to Costa Rica is very important for us because in topographical terms, also culturally, and the not only the social culture, but also the governmental culture is very similar to us. So we can learn a lot from them. But I would love to know the receiver project. So maybe we can have very nice examples from them.
So, and one last, it's not a question, it's a comment, just that you know, it happens that with Loyola University Chicago, which is a Jesuit university over there, and with Oxford, for which Peter Roshit is just behind me, we are launching a project, an initiative for all the Jesuit universities in the planet, dedicated to food insecurity, which is looming in many countries, as you know, and which includes also water management and the care for fresh water, et cetera, et cetera. And so I'm just wondering whether La UCA could not be part of this initiative, and I would love to bring you in the loop so that we could collaborate on this and hopefully also help you, provide you with what you need.
Definitely. Yeah, we will be
Thank you.
Really, really happy to join you. Actually, we have been working, mainly talking at the moment, but dreaming with Loli that we could have small food production within our campus, but also in the rivers where we are working at, because people is already doing that. Even with this polluted water, they are growing tomatoes, they are growing vegetables, because food is basic, is a basic necessity. So
sure.
Definitely it's a project we are very much interested to work with.
Okay, so we keep in touch.
Definitely.
Okay, thank you.
So we started a little bit late, so we are now past the time. So if anybody needs to leave, they can leave. I'm gonna allow for one more question before we start. So Maria, if you wanna go, you will be the last question.
Okay, thank you. Thank you very much for your presentation. Muy bien, muy instructiva, muy buena. And I hope to have one question. Your university is committed to the ecological transition. Water and the management are the heart of our project. Do you have contact with the civil society to share your project to achieve the transition? If yes, how did you work to run your project to civil society? En español, pienso que vuestra universidad está muy comprometida con la transición ecológica y que el agua y su gestión está en el corazón del proyecto. Es que tenéis, como se dice, contacto con la sociedad civil, es que estás trabajando con ellos y cómo lo hacéis.
Thank you, Maria. Well, none of our projects can be carried on without working with civil society. That's part of the way we work at UCA. We always join civil society networks to share with them and also to work together with them for each of our projects. The impact our social network from the impact we have in our society is quite strong. And we have three pillars at the university. One is all this academic work, but also the research work, but the social approach and how to impact socially in society. So this is something we take very serious, and we carry on with that all the time. Maybe it takes longer, the project, if we only think about the research itself or only the academic work itself is easier. But when we join with civil society, projects normally take longer time. but we do not care. It's important for us to do that in that way.
Okay.
Thank you so much, both of you, for joining us and presenting this work. This is extremely interesting, and I don't know if Gal, if you already have their emails. Otherwise, I can put you in touch.
Yeah, please do this.
Okay, I will do this. And so I'm going to